Hi, everyone. This is section 2.4. We're going to start off with consecutive integers. And what are consecutive integers? Well, it'd be like, for example, 1, 2, and 3. Another example would be like 18, 19, and 20, 21, 22, 23, so on and so forth. But what if I don't know what my first number is? Well, my first number would be x. The second number is what we would call x plus 1, because with each of those, you're just adding 1. The third one would be x plus 1 plus 1. Otherwise, you would actually call it x plus 2. And so the fourth one would then be x plus 2 plus 1, or x plus 3. Okay? And so we will go over an example of that pretty soon. But the other thing you need to know are like consecutive even integers. What are consecutive even integers? Well, 2, 4, 6. What would be another example of consecutive even integers? Well, what about 50, 52, 52, 54, and so on? Okay? But once again, here, what happens when I don't know the starting number? Well, we call that starting number x. And the next one would be x plus 2. And then the next one would be x plus 2 plus 2. Or we would call it really x plus 4. And that would continue on and on and on. Okay? And why am I adding 2 each time? Well, what was the difference here? 2. What's the difference here? 2. Again, here, if I looked at those, the difference is 2. 2. And that's where that 2 comes from. Actually, I want to move this up here. Consecutive odd integers. Well, I would think that would be like 1, 3, 5, 7, ... It could be 91, 93, 95, ... Again, they just have to end with an odd digit, and 1, 3, 5, 7, they continue to go up. But here, again, I am going to be told I don't know what the first digit is. So that's going to be x. Okay? And the second one, well, because this is odd, surely it's going to be 1, x plus 1, and x plus 3, and x plus 5, and so on and so forth. Okay? So let's test this out. Let's make x equal to 3. Okay, so the first one would be 3. Then I would have 3 plus 1, which is 4. That's not consecutive odd integers. Huh. So that's not any good. So this is not how you would do odd integers. I just failed. Huh. Let's try again. Let's do x. Let's go back here. What's that difference? That difference is 2. That difference is 2. That difference is 2. So guess what? Excuse me. The next number would be x plus 2. And the following number would be then x plus 2, parentheses, plus 2, or really x plus 4. Followed then by x plus 4, parentheses, plus 2. And that would be x plus 6. And that would continue on and on. So take a look. Consecutive odd integers and consecutive even, for unknowns, they have the same equation. So don't let that confuse you. Whether they say consecutive odds or consecutive evens, it's going to be the same no matter what. Okay, now let's go on, and we're going to do, this whole section really is about application. So it's going to be word problems. They're really not that bad. You just got to stop and look at the problem. Just read the problem. So this says two consecutive numbers that sum up to 91. So I got two numbers. Number one. What is number one? I don't know, so I'm going to call it X. Okay. What is my number two? I'm not sure, but I know it's consecutive, so I'm going to have X, and I'm going to have X plus 1. So I know that the sum of those two numbers, number 1 plus number 2, so here's number 1 plus number 2, oops, they sum up to 97. Okay, so now I can combine, well, I need to get rid of the parentheses, so first thing first, let's get rid of those parentheses. And then I can combine like terms. X plus X is 2X plus 1 equals 97. So if I have 2X plus 1 equals 97, the first thing I want to do is subtract 1 from both sides, giving me 2X is equal to 96. Then I need to get rid of that 2 in front of the X, so I'm going to divide, giving me X equals 48. All right, so the first number is 48. What's the second number? This is number 1. Number 2 is, remember, is X plus 1. So I'm going to replace the X, which was 48, plus 1, which gives me 47. So no, the number 2 one is equal to 40, oh, not 47, 49. All right, now let me check. So, and I'm going to check by doing 48 plus 49, and does that equal 97? And, you know, if you're struggling with addition, subtraction, you know, you're unsure, put 48 plus 49 into your calculator, and you're going to find out, yes, that does equal 97, which is great. All right, here's another application type problem, okay? You've gone shopping and you've bought yourself a set of jeans and a t-shirt. And if they cost, the sum of the jeans and the t-shirts cost $82, you also know if the jeans costed $15 more than the shirt, what is the cost of the shirt and the jeans? So we need to find each one individually. So how much does my shirt cost? That's the first thing. Well, I don't know. So what should we call that? And we can pick any variable. I really like X, and I'm sure you guys are going to eventually too. Okay, what about my jeans? How much are my jeans? Well, it says jeans costed $15 more than the shirt. So my shirt costed X, and then I need to add 15 because for that $15 more. Okay, but now I need to find each one individually. So I know the cost of the jeans and the t-shirt, so the shirt plus the jeans equals $82. So how much was my shirt? I don't know, it was X. How much were my jeans? X plus 15. And that's going to sum up to be $82. Combine my like terms, so X plus X gives me 2X plus 15 equals 82. 2X plus 15 equals 82.